All right, students, I want to make sure that I hit this. Hopefully you guys can see this okay. Not sure that you can. There we go. Okay, good. Coming into view. So here are the things that we need to identify in our problem, and you'll notice that I fixed this. I made a typo in here earlier. We can see that f of x is 3x plus 2, c is 1, and the limit L is 5. And so the question is asking us to find a delta where the epsilon is choosing to be 0.01. So we even know that the epsilon is 0.01. So that's the amount of range we have to deal with in terms of our delta. So the first thing that we're going to do is we are going to go ahead and use our definition, formal definition right here. We're going to be using this component here. So we've been given an epsilon that's greater than 0. It is now our job to find a delta greater than 0 that satisfies this condition. So we're just going to write this in here. So we're going to do f of x minus L, and we need that to be less than or equal to epsilon. So now we'll just start substituting things in. F of x, well, that is 3x plus 2. L is 5. And we need that to be less than this epsilon. So now we can go ahead and clean this up. So this is going to give us 3x minus 3 is less than our epsilon. And then we can factor out a 3. And then this is about where the bell rang when we were in class. Now we're just going to divide this 3 over. I'm going to go ahead and use my calculator here to give us a nice decimal here. Or maybe I might write it as a fraction. We'll see. So we got to do 0.01, and we need to divide that by 3. And we get 0.00333 repeating. And I'm going to go ahead and convert that to a fraction, which is 1 over 300. So what that means is, this is our epsilon here that we started with originally, but now look closely. I'm going to rewrite what we have right here. In fact, let me do it in green because this is the important point. We've got that x minus 1 has to be less than, 1 over 300. That's all this work has produced this. Now I'm going to go back here to our formal definition. This is what we were working with. Now look at this. 0 less than the absolute value of x minus c has to be greater than or less than delta. Okay, so now I'll do it in a different color here. Let's do it in blue. So 0 is less than the absolute value of x minus c is less than delta, right? Well, we've already established that c is 1. So this is 0 less than x minus 1 has to be less than delta. Well, folks, look at this connection here. Absolute value of x minus 1, absolute value of x minus 1. So what we just need to be able to do here is we know that our delta that we want to choose is, actually, you can pick any delta less than 1 over 300 and it will work. So for example, if I picked delta to be equal to 1 over 301, which is less than 1 over 300, it will fall in this bound, okay? Now you can stop at this point here because this is essentially, I have found the delta that I need. And by the way, there's an infinitely many delta. Now we got to keep in mind that delta has to be greater than 0. You can't pick negative values for delta. But we've got our delta here, okay? And let me just go ahead and expound on this just a little bit. So according to this, when we've chosen this 0.01, so now we're saying that 5, remember we're talking about the epsilon, so that's going to be the limiting value. So we had 5 here for our L, and now we've got 0.01. So that means it could be 5.01 or it could be 4.99. That's what we have to fall into in terms of our epsilon. Now I chose my delta to be 1 over 301. I think that's what I picked. Yes. So let me just go ahead and do that on my calculator here, divided by 301. So I got my decimal here. So I'm going to store that in A. Now what I'm going to do is I'm going to use my function here, which is 3x plus 2. Oops. So I'm going to do my 3x plus 2. That's my f of x. And this is my delta. So remember, c here was, I think we said that c was 1. So since c is 1, that means I just need to make sure that I pick, well, 1 and 1 over 301, which would be the following decimal. 1.0033222259. I'm going to take that number and I'm going to store it in B. And now I'm going to take this and I'm going to plug it into here. And I claim that whatever that result is, it's going to fall within that band. So let's go ahead and do that. 3 times alpha B is 2. And I get 5. So let me write this more explicitly. So what is f of 1.0033222259? Or we could say it is f of 1 plus delta. Well, let's see what the calculator tells us it is. It tells us that the answer here is 5.00996677. By the way, does that number fall between those two numbers? Of course, the answer is yes. It does. And you might say, okay, Mr. Brown, what does that matter? Well, the reason that matters is I'm telling you we can play this game. It didn't matter that you picked this for epsilon. You could pick any number for epsilon that you wanted, as long as it's positive, and I can find you a delta. That's because the limit exists. If the limit doesn't exist, this process would break down. So we'll stop it there because I've been going on 7 minutes.